Okay, AP Cal, I thought we would work on using tangent line approximations today. So here we go. I think this will be helpful. So find the tangent line approximation of f of x equals 1 plus sine of x at the point 0, 1. Remember when we had this in algebra, if you don't mind. Just go back to algebra for just a second. We had this. We had y minus y sub 1 is equal to m times x minus x sub 1. Just want to tell you that we're still using that. It's just going to look a little bit different. So let's have it this way. Let's say y minus f of c is equal to f prime at, right, c times x minus c, right? So I wanted to kind of start there. So make sure you have this here because this is kind of the way we think about this in calculus. But I want to be clear about it. It's just the algebra that we've always known. So here we go with that. All right? And you're like, oh my God, he's erasing it. Rewind a little bit and pause, please. All right, so let's look at this for a second. First thing I'm going to do is this. Because I know I need f prime at x, I'm just going to take f prime at x. And the first derivative of 1 is 0, and the first derivative of sine of x is just cosine x, isn't it? So look at this for a second. I'm just going to start building these pieces back together. And I'm going to get this. I'm going to get y minus 0, because that's our x value, 0, isn't it? Is equal to f prime at c, right, times x minus 0. Let me say f prime at 0. But f prime at 0 is cosine 0, isn't it? All I'm doing is this crap right here. I'm just taking these bits and pieces and putting them in where they go. All right? So I'm just going to keep... Oh, this should be f of 0. And I know somebody caught that, and you're dying to let me know about it. So let's take f prime... Let's take f of 0. So f of 0 equals 1 plus sine of 0. And of course, sine of 0 is 0, so is equal to 1. So this is minus 1. Is that cool? Cosine of 0 is 1, isn't it? 1. So y minus 1 equals x. Right? 1 times x, 1 times 0 just gives us x, doesn't it? Just going to do a little bit more algebra and get y is equal to x plus 1. Is that all right with you? So here is the line tangent to the curve at that place. Right? So that's kind of the good news. That's the quick answer. But to do this as an approximation, we would have looked at this a little bit differently. We would have kind of set up a table and said this is x, this is f of x is equal to 1 plus sine x, right? That's our original function. And then here's our derivative function is 1 plus x. And we would have set this up, and we would have looked at it kind of like this, if you don't mind. So let's just take a second. Remember, we're interested in when x goes to 0. So we're going to make our approach. I'm going to put my approach here, and let's approach from maybe 3 places from the left, right? And then maybe 3 places from the right. And this is an important thing also for us to look at, because I think sometimes when people make their approaches, they don't realize we're supposed to approach from values less, so we're approaching this way, and then we approach from values greater, and our approach is actually this way, although out at the completed table, if some other mathematician looked at it, they'd be like, what in the hell? They wouldn't see an approach. But this is our approach number right here. We're trying to approach this number here. So let's use like negative 0.5 maybe, negative 0.1, negative 0.01. Can we agree that we're getting closer and closer to 0 because that's our point here, isn't it? And from out here, maybe we'll start at 0.5, and you're like, why wouldn't you write it here? Because I'm just trying to help you visualize the fact that we're approaching this way, right? And isn't it true that as we move this way on our chart, on our table, that we're moving closer and closer to 0? This value that we're most interested in is right here, isn't it? So we're interested in this. And as we do this, and this is calculator stuff, but it turned out to be 0.51 and then 0.902 and then 0.99002, blah, 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 blah. And then guess what this value is going to be? Well, look at this. When we, right, it's going to be 1 here. And then look, 1.009 here, 1.0998, 1.479. Hopefully you can see as we're making our approach here. Check this out. As we're making this approach here, this way we're getting closer and closer to 1. And as we approach from the opposite side, again getting closer and closer to 1. So this is really actually good news for us. When we test the derivative function, we're going to find something very, very similar. And we're going to say it's 0.5 here, which is similar to what we got on top. 0.9 here, 0.99 here. Guess what's going to be here? Yes, 1, and then 1.01, 1.1, and 1.5. Again, we look at our approaches, and we can see that our table is bearing out what we thought was going to be true, that as we move this way, we're going towards a value of 1. And as we approach from the opposite side, we're approaching a value of 1. So that's what we're looking for here, right? All right, you guys, I hope this is helpful. I'm going to do better examples. I just thought I'd throw something out easy. I hope that the first couple of things that you got were, one, the fact that this thing is going to look like this. Our new point slope theorem is going to look like y minus f of c is equal to f prime at c times x minus c. And that's the form that we're going to be using. All right? All right, you guys, if you haven't already subscribed, please do, and your comments are always welcome. Be nice. Don't talk about my mother. You're the greatest. Ciao.